The acrid smoke of a snuffed-out candle. The sensual pleasure of food. Smells surround us with an invisible haze. They can waken deep memories and even attract us to the opposite sex. Explore the senses of taste and smell next on Body Atlas. Like every other living creature, you are surrounded by smells. They influence the way you think, how you feel, and how you react. The nose, in all its glorious shapes and sizes, is the gateway to this extraordinary realm of sensation. It starts in the air around us, which literally smokes with invisible scent molecules. The nose feeds this information directly to the brain.
That's great.
For Anna and Tom, smell has the power to make or break their evening. It's an unconscious undercurrent beneath the niceties of their civilized dinner. Smell will give them an appetite and define the flavors of their meal. And the very smells their bodies produce will affect how they react to each other. Smell is the most primitive of the senses. It's a simple chemical reaction to the environment, yet it puts us in contact with a world of information. If we could see smells, the air around us would literally smoke. An invisible vapor of scent molecules fills the air with particles carrying aroma. They bounce and crash into us, and once we draw them into our noses, the brain interprets them as smells. 5% of this sniff of air goes to the top of the nose, directly under the brain. Here, folds of moist flesh warm the passing air. The vapor flows through a jungle of nasal passages to a region packed with nerve endings, a mere quarter of an inch from the brain. Smell molecules dissolve in mucus and are trapped by hairy receptors. Hugely magnified, this region resembles a coral reef. 5 million smell cells are crammed into an area the size of a postage stamp. With feelers outstretched, receptors wait to grab a molecule. Smell is determined by the shape of the molecule. Different shapes are perceived as different smells. When a smell cell reacts, it shoots an electronic signal through a thin layer of bone straight into the brain. No other sense is so immediate. Aroma molecules come in an almost endless variety. The scent of good cooking signals what's safe to eat and what's not. They can warn us of danger. Whether it's the fragrance of roses on a summer day or the stench of garbage rotting in the sun, a few molecules are all that's needed to trigger a response. Our sensitive nose is designed to sniff out odors, and it's placed to fulfill another important role. It's the main organ involved in taste. We use all our senses to enjoy our food. The sight and smell of a shiny red strawberry makes your mouth water. If it's underripe, you hear a crunch. A slithery feel in the mouth tells you it's overripe. Just the sight of this strawberry would make you think twice. Anna and Tom aren't having any problem with the look, the feel, or the sound of this meal. Eating is a feast for all the senses, but taste and smell predominate. Each of these foods contains dozens of molecules that make up its unique flavor. The moment food enters the mouth, our tongue and teeth take it on a roller coaster ride. They break up the food so it's easy to digest. The tongue is the powerhouse of this attraction as it tosses the food from side to side. After the food is well crushed, the tongue forms it into a compact ball for swallowing. As Tom chews, his senses determine whether the food is safe to eat. Hidden beneath the tongue's rough surface is a battery of sensors. They tell us whether food is hot or cold. They sample its texture and report back on its taste. Under the microscope, the secret world of the tongue appears. Taste, like smell, is a chemical sense. Here, a single taste bud lurks, waiting to capture flavor molecules. The taste buds in this tongue are busy sampling sugar crystals. Each part of the tongue has a specific job. It can detect only 4 different flavors: bitter at the back, sour at the side, salty at the front, sweet at the tip. Since only the tip of the tongue is sensitive to sweetness, ice cream takes on an extra tang when licked, but only for a while. Cold foods numb the taste buds, and the flavor disappears. The tongue may be the most obvious, but it's not the only organ involved in taste. The best way to enjoy a mint is to crunch it. Its released vapors drift up the back of the throat to the densely packed receptors at the top of the nose. This is where we sense its mintiness. And it's not just mint. Food vapors of all kinds assault our smell cells. 90% of what we perceive as taste is actually smell. Smell is 10,000 times more sensitive than taste. You can't taste much when you have a cold because food aromas can't get up your blocked nose. Smell triggers the whole process of tasting. It makes your mouth water. Smell something tasty, and under your tongue, a saliva gland squirts into action. Saliva helps us digest food and is essential for tasting it. The watery liquid dissolves flavor molecules so they can react with our taste buds. We can't taste with a dry mouth. There's a third perception involved in tasting, a special sense of touch. Tom has just used it. Spicy foods and pungent smells stimulate the trigeminal, a supersensitive nerve running around the inside of his mouth and nose. It makes our eyes water from a hot curry or an unwise helping of mustard. But smell dominates the savor of flavor. That's why professional tasters are called noses. These wine tasters know that their art is as much a matter of smell as taste. The room has been carefully prepared. No flowers, no smoking, no smells that could distract their noses from the subtle message in a wine bottle. They have prepared their palates by avoiding harsh food and drink, such as coffee, which deaden the taste buds.
This is that gentle spiciness, isn't it?
Fruits there, it's nice.
The tasters protect their noses by avoiding aftershave or hairspray.
At the back of the palate, when it finishes.
This taster's palate is so sensitive, he can pinpoint the vineyard where a single grape was grown. He can even tell you the year. The soil, climate, and winemaking customs all subtly alter the chemical composition of wine, and thus the taste. A connoisseur may spend years investigating the tastes that make up the complex flavor of a wine. He sucks lemons for acidity, sniffs freshly sawn oak logs, and sucks tea leaves loaded with tannin, learning to instantly recognize each flavor component. He checks the color of the wine and then swirls it to release the vapors. This odd gargling releases more of the wine's flavor molecules. The wine delivers its 4 basic tastes to the tongue. As he draws air through the warmed wine, the back of his nose is filled with its complex aroma. Anna and Tom don't have trained noses, but even the average sense of smell is incredibly refined. A tiny change in just one of the 600 chemical components of coffee will make it seem bitter. Smell is unique among our senses. It has the most direct route into the brain. The nerves that pick up smell are virtually an extension of the brain itself. And unique among brain cells, they renew themselves. Smell cells continually divide and grow. You get a new nose every 2 or 3 weeks. Blast out your taste buds with a really hot chili, and they too will regrow. The nerve cells in the nose fire straight into the limbic system, the brain's memory bank. Smell something once, and you'll never forget it. The reaction is an age-old defense mechanism that protects the body. Eat or drink something that makes you sick, and it will always repel you. But smell's survivalist roots have an unexpected consequence. With a whiff of candle smoke, we feel the excitement of Christmas. The scent of the sea can take us back to childhood vacations. Smell is the most evocative sense, deeply connected with memory and the emotions. Smells can excite or relax us. They can arouse us or make us romantic. An aura of mystery surrounds this elusive power of the brain, captured in the ancient art of perfume making. For centuries, perfumers have created their own secret recipes from a range of fragrant ingredients. Roses and jasmine provide sweet aromas. Citrus fruits and berries, a sharper scent. An exotic touch comes from spices, vanilla, dried roots, oak moss, incense, and myrrh. Synthetic smells can provide the pungency of a snuffed-out candle. Every perfume house has its own library of smells. The seduction of musk, the zest of pine, all captured in a bottle. Blending these fragrances is the essence of the perfumer's art. No words can truly describe aromas, so perfumers borrow terms from the other senses, such as green, sharp, even caring. And because smells are tightly bound to our emotions, they influence our perceptions. The sharp scent of fresh lemons seems clean. The sultry tang of jasmine whispers mystery. Scientists may analyze the scents chemically, but no amount of technology can replace the human factor. A professional perfumer has a working knowledge of over 1,000 fragrances. She blends aromas as a composer combines musical notes. Sniff the perfume. The first smell is like the top note of a musical chord. It's the most volatile ingredient. It soon evaporates, leaving more lasting fragrances, the middle and base notes of her composition. The evening's going well. Anna is determined to look and smell her best. Smell dominates our lives, consciously and unconsciously, from the moment we are born. Smell and taste are a baby's first senses. They work well before his sight and hearing are fully developed. The first taste buds developed when the fetus was just 7 weeks old. He may have acquired some food preferences then, as spicy aromas seeped into the fluid-filled womb. While breastfeeding, an infant learns more about the flavors of his mother's world. The aroma of what she eats, maybe even the perfume she wears, gets into his milk.
Hungry boy?
Soon, these tiny food critics develop taste preferences. If the mother has been eating garlic, most babies will suck longer. They'll take less if she's had a glass of beer.
Tiger baby.
The early bond between mother and baby is forged through smell. His first smell is his mother. At just 6 days old, he can single her out by smell, although he can't recognize her by sight. A cloth carrying her scent will calm him down, and it's a two-way street. She can pick out her own child's garments, from a pile of dirty clothes.
Yes. I am a good.
One sniff, and the effects can spread to all corners of the brain. As a woman samples perfume, a brain activity scan demonstrates the power of smell. Hot spots light up in the front of the brain as it stirs memories. Areas in the back of the visual cortex show she's picturing a scene. The brain of a 3-month-old baby shows an even bigger reaction. His first smell of chocolate floods all parts of his brain with sensation. Smells also trigger the pituitary gland, which controls the body's hormone system. Its chemical messengers influence our health and our moods. Clearly, smells play an important role in human behavior. They may even put us in the mood for love. The smells our bodies produce have a surprisingly strong effect on other humans. As we get closer, or simply hotter, we begin to produce our own body smells. It's an odor as individual as a fingerprint. The smelliest regions are our armpits and sex glands. Here we have a huge number of glands producing oil and sweat. Each of us has 2 million sweat glands. Sweat itself has no smell, but bacteria break down the secretions and release body odor. A whole colony of bacteria thrive on this single armpit hair. This woman is waging chemical warfare against body odor. She is a deodorant tester, a soldier in the battle against offendingly foul bacteria. We go to a lot of trouble to disguise our natural smells, but the most potent of all sex attractants is secreted by our own skin. A molecule called a pheromone may make ardent lovers out of us all. Many foods are said to be the messengers of love. Scientists dispute that aphrodisiacs exist, but all these foods have a startling common thread. They contain a chemical identical to human pheromone. The molecule found in human odor and aphrodisiacs is similar to the male sex hormone, testosterone. Incredibly, they are alike except for a couple of atoms. Is this just a chemical coincidence, or have the romantics been right all along? Underneath, are we all just animals? In our brains, smell signals must pass beyond our primitive brain to our conscious mind. No matter how tempting, we cannot be led by the nose. The air around us is filled with a symphony of conflicting smells and sensations. We may never understand them, but we cannot ignore the elusive mix of mystery and memory that is the power of smell.